I have sent you the data set. Please download it.
Tomorrow we have holiday.
Yeah.
We get some rest after so many months.
Rest. Why?
1 day.
December first week, you had 2 days holiday, no?
Hi, yeah.
But we were in the tension of mocks.
Mocks.
Those didn't happen in the first that week. So holiday week, discussion today that it will happen in the holiday week.
Okay. लटका के रख दिया क्या? Good morning, everyone online. Ankita, Yash, यश तो यहाँ पे है. केशव.
Good morning, sir.
I have sent you the data set on your email. Please download it. It is called tradeinventories.csv. Mila data?
Yes.
Okay. So you can see here that we have a data set which is having two features. One is called date and the other is the value that we want to forecast. So this is what we call as a univariate analysis. Okay, we have only one data and the driving column is the date column. Okay, so date should not be considered as a feature. Okay, so we have data starting from 1st of January 1997 and it goes till around, you scroll down.
Two thousand
2018. Okay. So can you tell me what kind of a time is this?
monthly. The lag is month.
Month-wise. Okay. So we have 264 data points. So when we are splitting the data, it is going to be from 1 to whatever number, 70%. Test will be from, let's say 200. So 1 to 200 will be trained, 201 to the last one will be test. And the future forecast will be, can you guess what is going to be the date?
It will be 90. Depending on.
First January of 2000.
The next date after this.
Okay, it will be 01/01/2008.
What is the last date?
12/01.
So what is the next date?
Okay, 13/01.
So the future forecast will happen from the next day or the next time period that you have. Future forecast. Isn't it? Because our data is a daily data.
Sir, the data is monthly, I think the first one.
Is it monthly or daily? Just check.
MMTDY.
Ah, sir, it is monthly. The first one, I think it will be.
So 1, 1, 2, 1, 3, 1, 4, 1 till 12, 1. So it's a monthly data. So not daily. So the month, correct. Okay. Now, when we read this data, can you tell me what will be the data type of date? It will be string. Okay. So we have to first convert it into a date and time format so that Python recognizes that as a date time format, not a string format. Only then you can do time series. Otherwise, you will get errors. Okay. So parse this as a date and time. And then inventories, which is the second column that we have here, that is going to be the feature to predict. So this is a univariate analysis. Clear? Okay. So I'll just close this and look at the data. So we have number of inventories for that month. Either it is sold or whether it is existing. So that really doesn't matter. So we have 1 lakh, 13 lakhs, 161, then 130,780. So we have all these numbers. So what is the forecast that we have to do? That is inventories for the next n months. What are the conditions for forecast?
Monthly.
Condition. What did we learn last week? Hmm?
Data stability.
Stationary. Data has to be stationary. So how do we check for stationarity of data?
We'll plot it first.
Very good. We have to plot the data.
We have to check if it is trends or not.
Correct. So stationary. So this data has to be stationary. That means there should be no trend or seasonality. Okay. So how do we get it? We will plot it. Okay. So if it is not stationary, we have to make it stationary. So what is the method for that?
Smoothing.
Differencing.
Differencing.
So we'll subtract this from this, this from this, this from this, this from this, and then do the differencing. What is the model called?
ADF.
ARIMA.
ADF is a technique.
ADF is a technique to find the value for P and Q. ADF and PA, not ADF, ACF. Okay, ADF is a test to determine stationarity. Augmented Dickey-Fuller test. Correct. Okay, so let's get started. I'll close this.
This meeting is being recorded.
So we'll start with the libraries first. So first thing is import pandas as PD. Next, now whenever we are building these models, there are chances that we might get some warnings. Okay, now these warnings are really long, very difficult to interpret. So there is a technique to suppress the warnings. Have you done that? Ignore warnings? Correct. So we will do that. Okay. So we'll import warnings. Next, we will check what are the components of our data. What are the 4 components?
Any outliers?
Components. So we have SCSI, those 4 components. Okay. Now for checking these components, we have a library called seasonal decompose. So from stats models dot time series analysis dot seasonal import seasonal decompose. So this will give you the 4 components. So from stats models.tsa.stats tools, we have 3 libraries. ADF for checking data stationarity, then ACF auto correlated function, and PACF partial auto correlated function. These are tools for checking the value for the ARP model and the MAQ model. That is, what is the optimum number of lags for P and Q? So in case we want to make a difference of the data, we can use one library from stat state. Then for building the model, we have ARMA or ARIMA. Yes, okay. Friends, okay. ARIMA test. Yeah. Okay. Then we have to import the mean squared error. So what is this junk box test? What is the use of this?
Check auto correlation. Check auto correlation.
It is to check whether the model is a good model by checking the errors for normal distribution. याद है? Junk box test. And then finally we have MSE. This is to check whether the errors of our prediction. Now we will read the file. So file name, I'm going to give the path. So D:, ages. We check the path. Data set. series. So data equals pd dot read underscore csv file name. Now this is where we have to include a couple of more parameters. The first one is we have to convert our date into a datetime format, or it has to be parsed as a date. And number two, it has to be converted into an index. So first we will write index column equals date. What is an index? In pandas, what do you mean by an index?
Index is the number assigned to the data. Assigned to value.
Assigned to a value, assigned to a data. Correct.
Is the row index is the
Row number. It is a row number. The default row number is 0, 1, 2, 3. You must have seen that on the left hand side. Okay. So here we don't want 0, 1, 2, 3. We want the row number to be the date. So we are going to assign the index column to be the column called date, because it is a univariate analysis. And we have to treat the date as a date. So we will use parse dates. File not found, correct? D colon pages. Oh, sorry, not D colon, F colon. So now you will see here that my data has one column called inventories, and the index is the date. Done till here? Done? Okay. Next. Any guess what should be the next step? We have read the data. Next. Correct. We have to plot the graph to find out whether it is stationary or not. So we can simply write BL Okay, just lot. So now you plot the data and tell me whether there is a trend or not. So what should we do? We have to detrend it, okay, or remove the trend. And you can also check for the other components. Just put a semicolon there, otherwise you will have two separate graphs. So there is definitely a trend. There is definitely a random component. What about seasonality? So the two things that you have to study is trend and seasonality. Is there a trend? Yes. Is there a seasonality? There is definitely a trend. Is there a seasonality? Now, trade inventories, you will rarely find a seasonal component, okay, because it fluctuates. So there is no fixed season as such. And what are the different ways you can identify seasonality? Number one, look at the axis label. It goes from -1000 to +1000. And look at the label for the trend. And see the difference. Okay, so it is not even matching, nowhere near these numbers. And seasonal component is never identical. Look at this graph. It is a copy paste of the previous one. Okay, so you'll never have a seasonal component like this. You will only see a trend in the season that yes, there is a peak, but never the exact graph. So this is almost a identical graph. So that means there is no seasonal component. Clear how to identify? So since there is a trend, detrend the data before forecast. Okay, now you can also check using the augmented Dickey-Fuller whether your analysis is right or not. So before we detrend it, you can check whether the data is stationary. So we'll write a small function because we'll be using this 2 times. One with the actual data, and if it is not stationary, we'll again check for stationary after differencing. So we don't have to write the same code again and again. So one small function called just give me 1 minute. So we'll use this function called AD-Fuller. We have already imported this library, AD-Fuller, from the stats tools. So AD-Fuller will take the data as the parameter. So here we will pass for which data I want to do the test. Okay. Now let me show you the output of this function, what it actually returns. So AD fueler data dot inventories, or you can simply write data. Okay, so you can see here that it returns a couple of values. Okay, now what you're interested is in the second parameter. That second parameter is the p-value. Okay, it returns a couple of values. The second one is the p-value that we have to check. Okay, other things we don't require it right now. The first one is that test statistic, then we have the confidence interval, then we have the record length, all these things. Okay, so right now we don't require it, but p-value is something that we want. So we will check only the p-value. So within brackets, we will write 1. So this will return the p-value. Okay, so we'll write here p-value equals AD fueler of data and within brackets 1. Okay, and now check if p-value is less than 0.05, print data is stationary, else print data not stationary. So now we will difference the test. So now we have two methods. How to find stationarity of the data by using the graph and by using the hypothesis testing called as ADF, augmented Dickey-Fuller test for checking stationarity. So here you can write ADF test to check data stationarity. Done?
So can you just scroll up where you have converted the date column to?
Parse dates here. It is not actually converting it. It is going to internally consider any date column that you have or any column which is in a date format. It will consider that as a date column so that it is easy for your calculations or any data processing in date format. Tejas, ho gaya? Okay, so now let us detrend it. So we have included one library here called diff. Here. Okay, so we are going to use this function. diff. And we are going to pass for which column we need to do the difference and how many difference that you want to take. That is 1, 2, 3, how much? So we'll start with 1, or that is actually the default value anyway. Okay. So data of inventories. And how much you want to difference. So by default, it is 1, but always good to specify this. And I want to store the result of this into the same data. But I'll create a new column here so that you can see what has happened to the data. So here I'll write diff data 1. Okay, so I'm creating a new column called diff data 1, which is a difference of 1 of the original data. Now I'm going to print the value and see what I get. So data.head. So let's print the first 10 records. And now see, can anyone tell me how to interpret this data? Or how did you get these values? So the first one I'm getting is a NaN. What is NaN? Not a number or a null value. Okay. So this is null. ये null क्यों है?
Because it don't have the value to compare.
So 1301161 minus null equals null. Okay. So you get null. 1307080 minus 1301161. That is 5919. So 2 minus 1, 3 minus 2, 4 minus 3, 5 minus 4. So you get these numbers. Clear है ये? Yash,
Yes.
Tejas,
Yes, sir.
Manish,
Yes.
online, Ankita, Keshav. Okay. So now that we have differenced the data, now what should be the next step? So what is the use of doing the differencing?
We train the data.
We have differenced it. So now we have two data sets, original data, difference data. Now what should we do before building the model?
We will split the data into ADF test.
ADF test on?
On the second one, the difference one.
Correct. So we have to now check whether the difference data is stationary. Your model cannot be built unless your data is stationary. So that is why we are doing this, isn't it? So inventories is not stationary. So we are now going to check whether diff data is stationary or not. So now you can call the same function, check stationarity. Now use data dot diff data 1. Okay, now it is saying XOR contains INF or NANS. Okay, so your data cannot contain any null values. So we have to use dot कहाँ गया मेरा विंडो? Allah, I lost my changes. क्या कोड था यहाँ पे लाइन 54 के बाद?
Sir, we data diff dot
डिफरेंस क्या था क्या? ओके, so data of my screen crashed, I lost all the changes, equals difference of data dot inventories, क्या था, k underscore diff equals 1, यही था ना? Okay. And now check if difference data is data dot this data one dot. Okay, so just include this. Check stationarity for the difference data, but because we have a null value, so I'm using the drop NA function to drop the nulls before you check the stationarity. So now you will see that the data is stationary. So what should be the value for D? अभी ARIMA model में क्या-क्या parameters है? P. What is ARIMA model? It is a P, D, Q model. P is determined from PACF graph. Q is determined from ACF graph. D is determined from the difference. Okay, so now we have determined D, which is 1. Is this clear? Okay. So you can just write here D equals 1. Now we are going to plot the PACF and ACF to determine significant lags, that is P and Q values for ARP and MA.
So by default, D will be equal to 1 when the data is stationary, right?
Sorry?
By default, D value will be equal to 1 when the data is stationary.
I'll tell you how to do that. See, there are two ways in which we have to handle it. Let me share the screen. So this is the first set of data. I'll say actual data. And here I'll call this as difference data. Okay. Now, if the actual data is not stationary, this is not stationary, and this is stationary. Okay. Now, we have to build the model. I can either use this or I can use this. Okay. Now, what is the difference when I use the first model, the first data and the second data? Now, if I use the first data by using the ARIMA function, assuming that the value for P is 1 and Q is 1. Okay, let's say 1, 1. So I'm going to specify the value for P as 1. What is the value for D if I'm using the actual data? If I'm using the actual data, which is not stationary, what is the value for D? Here D becomes 1. And then Q becomes 1. Clear here? And this is actual data. If I don't want to use the actual data and I want to use the difference data, so my model parameter will be ARIMA. What is the value for P? It is 1. What is D? It is going to be 0. Q is 1. And this is the difference data. See the difference between these two. Both are identical, but the way it is called is different. Now, can you tell me what is this model on the right hand side? We covered this in the theory last week. What is the model on the right hand side? What is it called? This is known as the ARMA model. And this one on the left hand side is an ARIMA model. क्या difference है दोनों में? ARMA and ARIMA.
Difference.
When the D value is 0, it is an ARMA model. When the D value is not 0, it is an ARIMA model. So it depends what is the data that you are passing, that will determine the value of D. अगर आपने बाय मिस्टेक इंटरचेंज कर दिया, okay, if you give the value of D as 1 and you give the data as the difference data, then you will get a completely different result. Okay, so be careful with this logic. Actual data है, non-stationary है, give the D value. अगर stationary data as an input है, then give the D as 0. Clear? Fine. So let's go to the code now. Now we are going to plot the ACF and PACF. Now for how many lags you want the ACF and PACF? I told you how to read an ACF graph. What is the name of the graph? Yes, Yash, Komal.
Please go.
I think I should have a small cane. It is called the graph. Okay, so that will be the value for P2. So along the x-axis, you have lags. Along the y-axis, you have the correlation, right? Now, for how many lags you want to find significance?
So in our case, it is 1 month, that is 50 days.
1 month is not a lag. That is a time period. We want to find out how many lags are significant. So do you know how many lags you want? We do not know. So we give a random number. Let's say I want to find out from 50 lags or from 60 lags, how many significant lags I have. Okay, so that number is your choice. We can give 40, 30, whatever number, 100. Okay. So since lags are not known, so start with a random number for lags and try to give a medium number, not too small, not too large. And based on the output, you can change that number to a different number. So lag. So we can write lag ACF equals ACF now for which data I want to do the ACF and PACF. So let's do that. So we have to do it on the difference data. Okay. So we'll take data dot diff data 1 dot drop NA. Okay, so this is the data that I want to find out. What is the significant lags? So here I'll write diff data. And for how many lags? So here I can give any random number, let's say 40, for example. And then lag underscore PACF equals PACF on the difference data. PACF. Always write PACF and ACF, PQ. Now, if you look at these values, they are nothing but the correlations. Now we are going to plot it. Okay, these are correlated values. Can you tell me, do you remember how to identify the best lags? What was that technique I told you? You start with a confidence interval. And then there is something called as an error band. Isn't it? So we have an error band. So this error band is nothing but the confidence interval. So how much you want. So that error band is nothing but a Z-score. Okay. So this is that Z-score, this line. Now, what are these error bands? They are the, yes, what is that? They are the interval estimates. Okay. Now, how do you calculate these interval estimates is using the standard error formula. What is the formula for standard error? It is sigma upon square root of n. So here, what is the sigma value? This number. Okay. So if I take the confidence interval as, let's say 99.5 or 97.5. So 97.5 means what is the Z-score? 1.96. If I take 95%, 1.645. So that choice is yours. Okay. So depending upon the sigma, we are going to find the standard error and then calculate what is the plus error band and the negative error band. So first, let us calculate the standard error. So standard error. So what is the total number of observation? That is going to be length of difference data. So there are 263 records in my data set. Then standard error is sigma upon square root of n. So sigma, I'm going to take this as 1.96 divided by square root of n. Square root is not defined. Acha, so you need to define square root. So you can write, so from math, import square root. Very good. Now we'll plot the PACF and ACF. So this is the PACF. One row, two columns in the first one. Okay, so because it is a correlation, the data goes from -1 to +1. So the center line is 0. And now I'm going to plot the minus and the plus, which is the range. So PLT dot axis horizontal line y equals minus SE and you should be able to see this graph. Are you able to see the graph? Okay, now do the same thing for ACF. You can just copy paste the code here and minor changes. This is one row, two columns, second position. This is going to be ACF. And here it is going to be ACF. That's it. Now run both these. Now you can see I have the correlograms that is going to determine the value for P and Q. Okay, हो गया? Now, how do you determine the best values for P and Q? How do you determine the best value for P? So this will give me the value for P. This will give me the value for Q.
We will check for the
What was the logic to determine P and Q?
you can check for the joints where the joining, like the elbow joint.
So we have to find out how many peaks cross the lower and upper error band. Okay. So find out how many such peaks are there. So this is 1, 2, 3, 4, 5. This is just touching. So if you want, you can consider or you can leave it. This is the correlation with itself. So I can write it starts from 0 and goes up till 6. ये clear here? Same thing goes for Q. How many peaks are there that cross these red lines? So here we have 1. I have 2. Then I have 3. So Q goes from 0 to 3. So 0 means there are no significant lags. Now, which is the best combination for P and Q? I do not know. I have to do the cross validation. Now, assuming that there are going to be 0 to 6 and 0 to 3. So how many models do you think will be built? 0 to 6 is how much? 7. 0 to 3 is how much? 4. So how many models? 28 models for every combination of P and Q. So we'll have PQ 0, 0, 0, 1, 0, 2, 0, 3. Then 1, 0, 1, 1, 1, 2, 1, 3. Then 2, 0, 2, 1, etc. till the last. So you have to do it in a for loop and then find out which is the best combination of P and Q. And how do you get the best combination? What is the criteria for that? What did I tell you? Hypertuning say which combination is the best? How do I know P as 0 and Q as 3 is the best? By looking at the AIC and BIC scores. Okay, so let's do that. So for the time being, I'm going to take a random value. So I'm going to take a random value for P and Q. Okay. For ARIMA model. So I'm going to take P value as 1, let's say. What is the value for D?
0.
This is where you have to be careful. If it is 0, then you have to pass the which data?
If it is 0, then we have to find the original difference.
Difference data. If it is 1, you have to pass the original data. So be careful when you set the value for D. Okay, so I'm going to set the value for D as 1 and Q as 1. So what kind of an ARIMA model is this? This is an ARIMA 111 model. Because ARIMA is a PDQ model. Okay, so here I'm building a ARIMA 111 model. So this is an ARIMA 111 model. Is this clear to everyone? समझ में आ रहा है?
Yes.
Okay. So now let's split the data into train and test. In fact, let's do the splitting and then we'll set these values. Okay. So train data equals. Now, which data should I take? I have to take the original data. Okay. So data dot inventories dot ilog how much? रैंडम नंबर देना है या क्या है? How should the splitting be done for time series? Sequential split. Okay, so the first n records will be train. So either you can give a 70% or you can give a hard-coded number. The choice is yours. Okay, now how many records do we have? We have 263. So you can either take 250 as the training, 14 as the test. Okay, or you can take 70% of that. So 0.7 multiplied by n, which is 185. So either way, okay, so that choice is yours. So let's take let's take 225. So the first 225 records will be in the train data. And for the test data, it is going to be from 225 till the end. So now let us look at the train data. You will see this is train dot tail. Let's take the last three and test dot head. Okay. So the last record of train is 2015, 1st of September, and the first record of test is since it is in sequential, so 2015, 1st of December, 1st of October. So this is how you have to determine whether the split has happened properly or not. If there is any change, then you might get errors during your model building. Tejas, clear hai? Yash, Manish, Omal, Ankita, Keshav, any questions? Okay. So now let's build the first model. So let me call this as M1, ARIMA. And I'm going to take the train data. Now you need not give train.inventories because train data is already defined as data.inventories. Okay, so we can directly give the train data. Then you have to specify what should be the order. So here you give P, D, Q. Dot fit. Okay, compile this. P is not defined. Okay, so I need to run this. You might get some warnings. You can ignore the warning. हो गया मॉडल बिल्डिंग हो गया Now we will summarize the model. So if you look at the summary, you will find, because it is a P equals 1, Q equals 1. So you will have the two coefficients for those two values. And look at the Z-score of these two. 23.3 and minus 6.7. So can you tell me if they are significant or not? You remember the equation y at time t. What is the equation for time series? Y at time t or y hat at time t equals
AR.
the constant term plus sigma of AR plus sigma of MA. ये सिग्मा क्यों है? How many lags I am taking? Isn't it? Since I'm taking only one lag, you are seeing only one here and one here. And according to 1, 1, both these lags are significant. Why they are significant? Look at the Z-score. 23.3, which is greater than the highest number you can think of in Z, which is 3.1 or 3. So it is significant. Look at the moving average value, minus 6.7. You take a modulus, sorry, you take the absolute, you get plus 6.7, which is again greater than the highest value. So both these lags are significant. AIC 4448, BIC 4462.
If the lags are not significant, then will increase.
Then you have to change the value for P and Q.
Can be anything.
So we have a range, isn't it? We have identified for P, it is 0 to 5. For Q, it is 0 to 3. So now, what you have to do, I'll give that as an exercise for P loop from 0 to 6. Then for Q loop, 0 to 3. So you'll be building the model and then checking for the significance, that is AIC and BIC. And then finding out which is the minimum AIC, BIC that you get. So that combination will give you the best sequence or best model. So I'll tell you how to get the AIC scores and the BIC scores. So AIC, BIC equals model 1.AIC, model 1.BIC. Print AIC So these are the AIC and BIC scores. Finished? Next step. So there are two more steps. First, we will check whether this model is good or not. Then we will do the forecasting. Then we will do plotting of test data versus the forecasted data. After that, we will do RMSE for the forecasted values. And number 5, future forecasts. Okay, so first we'll do the junk box test.
क्रॉस वैलिडेशन नहीं किया
क्या क्रॉस वैलिडेशन करना है इस पर?
मतलब जो वैल्यू जो अपन ट्रेन में दिया था जो
ट्रेन पे क्या दिया था?
जो वैल्यू दिए थे हमने जो इनिशियल थे
P and Q.
हाँ
हाँ वो अभी आपको ऐसा एक्सरसाइज वो करना है. I have taken, that's why if you look at line number 93, I have given take a random value. But this may not be the best value always. So now we'll go to the junk box test for significance, for model significance, that is. So the input for the junk box test is the residuals of the model. Okay. So we have stats model dot stats underscore is क्या नाम था उसका? Stats model STS, sorry. STS dot stats underscore there you go. So STS dot echo dot lunch junk box M1 dot residual. M1 dot resid is the residuals of the model, which is this one. Now for the number of lags, since we do not know for how many lags, so we give the number of lags as 1. And then let's see the output of this. Then, okay. So this is going to return us 2 values. Now one of them is the p-value. Now we do not know which one is the p-value. So there is another parameter here, which is called return df. That is return the output in a data frame format. So return data frame format equals true. Now see the output, we have LB underscore stat, which is the P statistic value, and LB underscore value, which is the P value. So this is what we want. Is this clear? Dot LB underscore P value. Okay, so I'm going to store this result as P value equals, and then if P val is greater than 0.05. Good morning. So this you have to do it for every combination of P and Q in your for loop. Okay, chunk box test. Now, what if it returns not a good model?
You will change the values of P and Q.
Correct. We have to change values for P, Q, D. Just check the treatment that you have given and then change it. So now we'll forecast on the test data. Now here, when it comes to time series, you have to specify exactly the starting and ending data points that you want to forecast. Okay, it cannot be a random forecast. So we have to give what is the starting position and what is the ending position or the starting or ending record. Can anyone tell me what should be the starting record?
For prediction, starting record will be from what, like it is 2019.
You have to specify the index.
264.
264. So instead of hard coding it, we can directly give length of train. Right? What should be the ending?
Length minus 1.
Length of what?
Data minus.
Length of train will give you what?
180.
Data which is in training.
225.
120.
Okay. Now remember, we have to specify the index position. Okay, not the date. So 225 is the 225th record. So from that, how much?
From that,
So-
265.
So how do you specify that? Length of train plus length of test minus 1. That will give you the difference. Correct? So do that. So length of train plus and then
Sir, it will be data minus length of train.
hmm?
Whole data minus length of train.
whole data. हमको कहां से प्रेडिक्ट करना है?
226 data.
So how do you get to the 226 position? length of train. Remember Python means it starts from 0.
Yes.
Okay. So from that position, I have to come down till the last. Now there is another parameter. Okay, let me ask you this question. If I predict using these parameters starting and ending using the model M1, what is going to be the format of the predicted value? Will it be the original data or will it be the difference data? Think and tell.
So in this case, we have given the difference data, right? So it will be the difference data. We are predicting on that data.
No?
We are predicting on.
He has a different opinion. Okay. Now, bolo Yesh. Question clear? I have built a model which is M1. Now, when I'm forecasting it, will it forecast with the original data format of trade inventories or will it forecast the difference value of trade inventories? In दोनों में से कौन सा होगा? That is very important. Otherwise, 1000 is the actual value. You are forecasting 20, you will do 1000 minus 20, which is wrong. Think and tell. Yeah, what Komal said was right. We are passing the difference data. Isn't it? D equals 0. Sorry, D equals 1. But what data?
The difference.
Actual data. Actual data is getting passed with a D equals 1, which means internally it is going to differentiate. So when you are forecasting it, you will get the difference data. So here, if I use the predict function, it is going to give me the difference data. But I want the data to be in my original form. So that is what the third parameter is. Whether you want the data to be in its original form or differenced form. Okay, so that is called TYP. समझ में आ रहा है? So use this parameter called levels, and this is going to forecast it in its original format. Okay, now if you want to see the difference, if I do not give TYP equals levels, see what happens. I'll do M1 dot, let me just put this as F2. M1 dot predict start, comma, end. Now see the difference.
Values are different.
The F2 is this one and F1 is this. Which is the original data?
The levels.
The original data form kya hai? It has a 7-digit number, right? What is F2? The forecast 2 in its differenced form. So when you give type equals levels, it is going to predict it in its original form. Okay, so let's make a note here. TYP equals levels will forecast in its original price. So here forecast in the difference file. So now you can store the results in data frame for analysis. So we can call this as result equals pd dot data frame. The actual data, which is nothing but the test data. And forecast is one dot values. So 2.03, what is the meaning of E plus 0.6? .03 E plus 0.6. क्या मतलब है इसका?
It is 2 that plus 0.6 is 6 digit before.
It is 2.03 into
10 raised to
10 raised to 6. जो हम लोग स्कूल पे करते थे ना फिजिक्स में, स्पीड ऑफ लाइट. So now multiply this by 10,000 and you will get the value as 2034823. Okay? So there is no decimal place here. Now, how do you calculate the error here? So RMSE and MSE you can calculate. So MSE equals mean squared error. We have already defined that library. df res dot actual data frame result dot forecast. RMSE equals square root of MSE sprint model 1 equals D equals Q equals format So there will be some errors in the forecast. Okay, so this is only our first model. So we can see that it is giving us a kind of exponential increase. Okay, so here we have a steady growth. So here it is a rapid growth, which is the forecast. Now, the last thing that we have to do is the future forecast. Can anyone tell me the logic for future forecast? Can I use the same model? Okay, we'll take a break and then think, then we'll.
Future forecast will show the values from 2019. We have the data in 2019.
So future is the last date that we have in the training.
I got the.
So it should be the next day after that. The next whatever thing will do. So tell me what should be the model building logic? Will it be the same or is there any difference?
The lag will be. So
No, we are assuming the same lag P, Q and D. That will keep it constant till the future. And then we will change it. We'll take a break. We'll meet at 11:30 and then we'll continue. Okay, online people, we'll break for 15 minutes. Okay, let us start. So the question I asked was, for future forecasting, is there any difference in the model building? What do you think? Online also, you can also answer, Ankita and
I think the name of the list what we have written now. Those will change.
Very good. क्या change होगा?
I mentioned.
So for the future, my training data is going to be the entire data set. Okay, because future में predict करना है, so I need the starting and ending date, which is going to be as of today, so that tomorrow I can predict. So my data set will be the entire data frame. Okay. So now there won't be any test because you have already done the validation using the test. And if you're happy with the result, now build the model on the entire train data. That is going to be your train data.
And so then we have to give the.
Yes, that is the future. Okay, so that is the difference. So we have to build a new model. So if you look at the model definition here, so here we have taken ARIMA train. So here it is going to be ARIMA. This is going to be data dot inventories. Okay. Order will be PDQ. Dot fit. And then for forecast, I'm going to use the M2 dot predict. Now, what is going to be the starting number? It is going to be length of data. So that is the starting. And what is going to be the end? So for how many time periods you want to do the forecasting? Okay, now what is my time period here? It is month. Okay, so here you can specify. So length of data plus 12 will give you
Next 12 months.
the next 12 months or 1 year. Okay, so look at the data. The last record is what? 2018, 1st of December. Right? Last record. 2018. Now look at the predictions for the future. 1st January 2019. So here it is 13 months. Sorry, 1, 2, 3, 13 months, because I have given the value as 12. It should have been 11 actually.
That means due to pandemic, all the predictions made in 2019 were false. 90%.
That depends on how the business is. Because even in pandemic, businesses were affected, but the business was not as expected as it should have been. So you will see.
We don't have any data like for a pandemic how it went. So how would they predict 2020 data if they were asked?
See, no one saw 2020 coming. So the forecast definitely would have taken a hit. See, forecasting happens 3-4 months in advance.
If I want to apply this forecast into my existing Excel sheet,
Write it into the CSV.
I change the values as well. Like it is plus e raised to the power 0.6.
That
Function you can use.
no, this is a format. Once you write it, the value will be automatically transferred.
ACS, okay.
So now you see that the values that you see in the future forecast is similar to what is there in the actual data. So now we will do the plotting. So we'll first convert this into a data frame. Take a different color. It is actually merging with blue. Let's take red. So now you can see that I have my original data, which we plotted right at the beginning. And then I have the red line, which is the future forecast, that is from 2019, January to 2020, 2019, December. So I can see there is a positive trend in my future forecast. Yeah, so this is the overall way that you have to implement. So now your exercise is find out the optimum PMQ. Right now I have taken 1, 1. So now using a for loop, so this code will remain the same. So what will now change is the value for PMQ. So convert this into, if you want, into a separate function. And then using a for loop, take P, take Q, and call the entire thing, get the AIC, BIC scores, and create a data frame to store PQ. D is constant. So if you want, you can put PDQ, AIC, BIC. So you'll get 28 such results. Then select the minimum value for AIC. Okay, so do this exercise.
That when we take first difference, right? So then do the data not
Stationary.
stationary, then we take the difference. Second,
Not difference of difference. Lag of 2.
That,
Difference of difference will not give you the result. Difference of 1 is 2 minus 1. Difference of 2 means 3 minus 1.
Then if we take that, okay, then we'll pass the difference 2 for training and testing.
Correct.
And then D will be equal to
2. 99% of the time, the difference of 1 should make the data stationary.
And if already the data is stationary,
Then it is an ARMA model. Then it is ARMA model. So D is 0.
Only P and Q value.
Correct. Keshav, Ankita, any questions? Okay, so do the exercise of looping through all the values for P and Q. So you can create a list like this. List of P. I think the value was 4, isn't it? So start from 0 to 5. So now loop through for every P, build for every Q, and then we do this. And that completes time series.
This PQ value will change only after or it will change from the
beginning. You have to complete that full cycle of model building till future forecast. Everything should have the same set of values, PQ. Acha, you have a session today after 1. and finish this. We meet next Saturday then. Okay. So online, Ankita and only Ankita is there. So we'll meet next Saturday. Tomorrow there's no class. So finish this exercise, and if you are having any issues, let me know. There is actually one more thing that I want to do in this chapter, which is the smoothing technique. So maybe we can spend some time in doing the smoothing technique also before doing the Tableau sessions.
What is the effect of smoothing?
Smoothing is short-term forecasting. What we have done here, same thing, but with certain conditions. If I don't have seasonality, if there is a seasonality, then if I have to do short-term forecasts, then how to do? Sure. So thank you. See you next Saturday.
calculation